In 1906, Robert Goddard, the father of American rocketry, first wrote about ion propulsion. At the time, spaceflight was more than half a century away. In the 1950s, Collier's magazine had an article about using ion propulsion for futuristic space travel. Ion propulsion allows us to undertake missions which would be impossible without it. First, let's remind ourselves how regular propulsion works. You take a gas and you heat it up or you put it under pressure and you push it out of a rocket nozzle. And the action of the gas leaving the nozzle causes a reaction that pushes the spacecraft in the other direction. Now, ion propulsion works on the same principle, but instead of heating the gas up or putting it under pressure, we give this gas xenon a little electric charge, and then the atoms are called ions. So we put a large voltage between two metal grids that are very close together, accelerate the ions out of the spacecraft at very high velocity, 90,000 miles per hour. And so the action of the ions leaving the spacecraft causes a reaction that pushes the spacecraft in the other direction. And that's what makes it so efficient. It would take Dawn 4 days to accelerate from 0 to 60 miles per hour. But instead of thrusting for 4 days, if we thrust for a week, or a month, or a year, or as Dawn now has for 5.5 years, we can achieve fantastically high velocity. And so this is what I like to call acceleration with patience. There have been previous missions and tests of ion propulsion to validate the basic technology, but Dawn now has made it a reality. Dawn's the only spacecraft ever in more than 58 years of space exploration to orbit 2 extraterrestrial destinations, the last uncharted worlds in the inner solar system. And it not only allows us to get to these distant bodies, but once we're in orbit, we can maneuver extensively in order to get the best possible science that we can from the mission.
At Vesta, we found a world that was beyond our imagination in terms of the compositional diversity, the different colors of the surface, the giant tectonic features, troughs, giant impacts that created huge basins in the southern hemisphere. And we also found these hydrated minerals on the surface, which were indicating that there was some water, which we couldn't have imagined before we got there. At Ceres, we were stunned to see these very, very bright spots on the surface of a very dark body. And in studying them, now know that they're giving us a window into the history of a subsurface ocean on Ceres, which froze out long ago and left behind frozen, salty material, which through impact processing is now displayed on the surface for us to study. Only because of the use of ion propulsion were we able to execute this amazing mission.
Ion propulsion is so powerful, it not only opens up new missions, it opens up new kinds of missions. For example, NASA is now working on a mission to send a spacecraft to an asteroid, pick up a large boulder, bring it back into orbit around the moon, and then astronauts will travel to that boulder and sample some of it, bring it back to Earth, and gain experience in deep space operations. And NASA now considers ion propulsion an essential ingredient of sending humans to Mars. It's been a century since Robert Goddard first wrote about it, and now finally we have spacecraft out there using ion propulsion to explore new worlds.